So we need to consider the given series. We need to find the first few terms of this series to show how it starts, and we also need to find out the sum of this series. Well, to find the first few terms, we substitute the value of n from 0 to infinity in a given series. So we get that I equals 5 over 2 to the power of 0 plus 1 over 3 to the power of 0 plus 5 over 2 to the first power plus 1 over 3 to the first power plus 5 over 2 squared plus 1 over 3 squared, and so on. This equals 5 plus 1, then plus 15 plus 2 over 6 plus 45 plus 4 over 36, and so on. So this equals 6 plus 17 over 6 plus 49 over 36, and so on. So since the given series is geometric series, we will use before we find the value of this series, let me explain. So here, for example, S1 equals 6, S2 equals 6 plus 17 over 6, S3 equals 6 plus 17 over 6 plus 49 over 36. So these are three first terms of the given series. Next, we know that this series is geometric series, so we will use the formula of geometric sum of infinite series, which is Sn equals a times 1 minus r to the power of n over 1 minus r, where a is the first term of series and r is the geometric ratio between every two terms. As the given series can be written as, so our series I can be written as the sum from n equals 0 to infinity of 5 over 2 to the power of n plus the sum from n equals 0 to infinity of 1 over 3 to the power of n. So if the series, the infinite sum of a n equals the sum of from n equals 0 to infinity of 5 over 2 to the power of n, and some series bn equals the sum from n equals 0 to infinity of 1 over 3 to the power of n. So if this series are convergent series, then it can be written in the form that the sum of an plus bn equals the sum of an plus the sum of bn. So this is why we can rewrite our series like that. And now we will check the convergence of this series by ratio test. So limit of an plus 1 over an, where n approaches infinity, equals limit of 5 over 2 to the power of n plus 1 over 5 over 2 to the power of n. This equals the limit of 2 to the power of n over 2 to the power of n plus 1. Wait, let me do it like this. And this equals the limit of 1 over 2, basically. 1 over 2 where n approaches infinity. So this equals 1 over 2 and it's less than 1. So since the limit is less than 1, so that means that the series is convergent. Now let's do the same for series B. So the limit of bn plus 1 over bn, where n approaches infinity, equals the limit of 1 over 3n plus 1 plus over 1 over 3n, 3 to the power of n, where n approaches infinity. This equals the limit of 3 to the power of n over 3 to the power of n plus 1, so it equals 1/3. Again, it's less than 1, so this is convergent as well. Convergent. So since we have proven that these two series are convergent, that means that our initial series I can be represented as 5 times the sum from n equals 0 to infinity of 1 over 2 to the power of n plus the sum from n equals 0 to infinity of 1 over 3 to the power of n. So by using formula of sum of infinite series, we get that this equals 5 times 2 plus 3 over 2, so it equals 23 over 2.